Hi guys, we're doing this chemistry paper today. This is the specimen paper for 2022 9701 paper 1. So from 2022 we have 1 hour 15 minutes for our exam. So remember that you're getting 15 extra minutes for your exam. And section B has been removed completely. So we only have single best answer questions. That means questions like 1 to 30. Alright, so let's begin. And there are no other huge changes to the syllabus. More or less everything is the same. A few things have been added to the syllabus though. In the analysis part, the formula on mass spectrum using carbon 13, right? That one. It's used to find out the number of carbon atoms in a molecule. Okay, so let's begin. Starting with question number 1. Which molecule contains 8 bonding electrons? So carbon dioxide, it's like this linear. So it has 4 bond pairs, right? Each bond pair has 2 electrons. So this into 2 is 8. So the answer is actually A. That's it. Why are the other ones wrong though? Check this out. Ammonia. Ammonia has 6. Okay. What about C2H4? C2H4. That's 1, 2, 3, 4, 5, 6. 6 into 2 is 12. That's a lot. Okay. You get these. These are wrong, right? Number 2. Beams of charged particles are deflected by an electric field. Okay, in identical conditions, the angle of deflection of a particle is proportional to its charge by mass ratio. In an experiment, protons are deflected by an angle of 15. In another experiment, under identical conditions, particle Y is deflected by an angle of minus 5. Interesting. What could be the composition of particle Y? Check this. Protons, okay? If you think of a proton, we can consider it to have a mass of 1, It has a mass of 1 and the charge of 1 as well. So the charge by mass ratio of a proton is actually plus charge 1 divided by mass of 1. That's actually 1 plus 1 basically. So what can we understand? Like the ratio of plus 1 gives an angle of plus 15. Okay, so clearly y is deflected by an angle of minus 5. So our particle must have a negative charge in total, or else it can't be deflected like that. Okay, so look at this. It can't be A because the net charge is 0. Okay, so it wouldn't be deflected at all. It's not A. Look at B. B is a probable candidate because it has a negative charge. C can't be the answer because it has a positive charge. D can't be the answer because it also has a positive charge. So this leads to the answer B. But what if they give you two uh, options with a negative charge? How would you approach the sum then? I'll show you how. So look at this. What's the mass of this compound? We're going to consider that electrons have negligible mass. The total mass of particle B is actually, 3 plus 3, 6. What about the charge? The charge is actually plus 3 minus 5. So that's actually minus 2 by 6, or that's a ratio of minus 1 by 3. So hear me out. Plus 1 gave us a value of plus 15 degrees. So what about minus 1 by 3? That will be one third of 15, and it will have a minus sign in front. So that's actually minus 5 degrees, and that matches with the question. I hope you get it. 3. The mass spectrum, like 2 was 10 degrees, was also possible if we had 2 by 3 or something. The mass spectrum of a sample of lithium shows that it contains two isotopes, lithium 6 and lithium 7. The isotopic abundances are shown in the table. What is the relative atomic mass of this sample of lithium given to three significant figures? Okay, so 7.42 by 100 into 6, right? Plus 92.58 by 100 into 7. This gives us a value of 6.9258 to 3SF, right? To 3SF, it should be 6.93 logically. So 3 is actually D. Moving on to 4, diamond, graphite, and the buckyball are different forms of the element carbon. Which statement is correct for all three substances? Bond angles of 120 degrees are present. Present in graphite and buckyball, but not in diamond. Okay, so 4 is wrong. Delocalized electrons are present, not present in diamond actually. Okay, giant molecular crystal. Okay, so the buckyball has a simple molecular structure. Sigma bonds are present. This is true for all of them. All of them have single sigma bonds. 5. A metal has total surface area of 150 centimeters square. It is evenly coated with silver by electrolysis. Its mass increases by 0.216 grams. How many atoms of silver are deposited per centimeter square on the surface of the metal? Okay, so to do this, by the way, you won't be given the data booklet anymore, but you will be given information you require. So for example, we're looking at silver, right? It has a mass of 107.9. Understood? So 0.216 by 107.9. That's the moles of silver actually. That's 0.216 divided by 107.9. 2.00 into 10 power minus 3. So if you want to find out the number of atoms, 6 multiplied by the Avogadro constant, 6.02 into 10 power 23, right? That gives us a value of 1.2 into 10 to the power 21. Okay, 1.2 into 10 power 21. So that is deposited in 150 cm cube. What about each cm cube? Divide by 150 to get a value of 8.03 into 10 to the power 18. Okay, so we're gonna go with 5a. 6. Nitrogen has a higher first ionization energy than oxygen. Which statement explains this observation? Look at the trend for them. It's like this, right? If you go to, wait, let me just copy this. Do you want me to, wait, here you go. Let's rotate this. Okay, we're good now. So yeah, if you look at the trend from lithium to fluorine, it's like this. Lithium, beryllium, okay, followed by boron, carbon, nitrogen, oxygen dips, right? Followed by, fluorine. So why is that? Why does oxygen have, or why does nitrogen have a higher first ionization energy than oxygen, right? Or why does oxygen have a lower one? Mainly due to the spin pair repulsion in oxygen. Okay, so oxygen actually has two or paired electrons in 1,2p subshell, but nitrogen does not. So that actually overweighs the increased attraction due to the increased number of protons. Okay, 7. Which molecule has the largest overall dipole? I think this is a very common question. In D, they actually cancel out. It's a trick question. The answer should be B. C also has a dipole, but it's not that high. This is really high because this is, del minus. These are electropositive. So it has a dipole towards this direction. The electron cloud is concentrated in that side. Okay. So B is the answer. I've seen this recently in another question I solved in 2021. Okay. 8. The complete combustion of 2 moles of an alkane produces 665 dm cube of carbon dioxide measured at 400 Kelvin and 189.5 pascals. Carbon dioxide can be assumed to behave as an ideal gas. So PV is equal to nRT. 1 into 10 power 5 into 665 into 10 power minus 3 converted to meter cube, right? Is equal to 2 moles. Wait, what's the purpose of this? Where am I going? Like if I use 2. Okay, so basically we are finding out, this is the moles of the alkane. I can't really input it here. This is the moles of carbon dioxide gas. Understood? So 8.31 into 400 Kelvin. So let's find out N. 1 into 10 to the power 5 into 665 into 10 to the power minus 3 divided by 8.31 divided by 400. That gives us a value of 20 moles of CO2 are produced, okay, after the after combustion. So what's our goal now? Actually, our goal right now is to find out which of these, out of these four, which one produces, like when 2 moles of the alkene is combusted, 2 moles of the alkene are combusted, which one produces 20 moles of CO2. So clearly the answer should be quite simple. It should be C, because 2 moles of C10H22 produces 20 moles of carbon dioxide, because 2 times 10 is 20, 2 times 20 is 40, 2 times 8 is 16, 2 times 5 is 10. Hopefully I could clarify, okay? But if you want proof, C10H22 2 moles plus oxygen is equal to 20 CO2 plus H2O. We should have 22 over here, right? Like that. Moving on to question 9. Which expression gives the standard enthalpy change of combustion of methane? Okay, so combustion of methane. So it's like this. Methane is basically combustion in the presence of oxygen to give us carbon dioxide and water, okay? So what's a way we can find out this enthalpy change over here, this enthalpy of combustion? They basically use formation, right? So formation is the enthalpy change when 1 mole of a compound is produced from its elements in their standard states under standard conditions. We need solid carbon, oxygen gas, and hydrogen gas, right? The arrows should point upwards. Okay, I'm not balancing it, but we need to balance it, right? So combustion of methane, it gives us 1 mole of carbon dioxide and 2 moles of water. How much oxygen do we need? 2 plus 2, that's 4, so we need 2 here. We just need 2 here, and yeah, 2 here should do fine. So we're actually, combusting 1 mole of combustion of 1 mole of methane is happening over here. And how many? So this is the enthalpy of formation of methane only. This is the enthalpy of formation of carbon dioxide, 1 molecule of carbon dioxide, and it is also the enthalpy of formation of 2 moles of water. Do you understand? So let's just follow the arrows. You can either take this direct route, or you can take the detour through here, right? So we can say that, del HF of methane plus the del H of combustion, right, is actually equal to del HF of carbon dioxide plus 2 times del H formation of water, okay? So if you make del HC the subject over here, this is a bit messy, right? Wait, let me try to fix things. Okay, so if you make del HC the subject, we're going to end up with formation of carbon dioxide plus 2 times the formation of water and minus the del H formation of methane. So that's what we're looking for. Let's see if we can find this. And logically, 9 should be D according to our findings. Carbon dioxide plus 2 times water minus formation of methane. Hopefully I could clarify. Number 10. Solutions containing chlorate 1 ions are used as household bleaches and disinfectants. These solutions decompose on heating as shown. Which oxidation states are shown by chlorine in these 3 ions? Okay. Here, oxygen has an oxidation number of -2. Chlorine has an oxidation number of +1. Here, oxygen has -2. -2 into 3 is -6. So chlorine is +5. This is chlorate 5. And chlorine has an oxidation number of -1 here. Okay. So we're going to go with C. 10 is C over here. Okay. 11. When K2MnO4 is dissolved in water, the following reaction occurs. What could be the values of A and C in the balanced chemical equation? Okay, how do we solve these? You guys have a lot of problems in balancing usually. That's what I know. Let's use, this is potassium permanganate. No, it's not permanganate. It's just manganese. It's a variation. So oxygen is -2, right? -2 into -4 is -8. So manganese has to be +6 over here so that the whole thing has a charge of -2. Okay. So manganese in MnO42 minus has a charge of +6. Over here, manganese, since this is -4, manganese has a charge of +4 over here, right? So look at oxidation number. It goes from +6 to +4. So the change is it gained 2 electrons. Next. Here, manganese, this is permanganate, has a charge of +7 since this is -8. So it also went from, this is +7. It also went from +6 to +7 over here. What's the change in electron number? That's actually 1, right? 1 electron was actually lost. So what's the trick in balancing 1 and 2? We just need to multiply this 1 by 2. 1 into 2 is 2, right? So check this out. MnO42 minus plus H2O is equal to Mn. Okay, wait. Why don't I take more space to do this? Wait up. 4 minus plus MnO2 plus OH minus. So yeah, do you understand the logic? Do you know what I did? This was +6 and this was, wait a bit. This was +6 and this was +4. So reduction took place. 2 electrons, and here +6 to +7 oxidation took place, 1 electron. So we just multiply this by 2. So there should be a 2 here and there should be a 1 here, then it should be balanced. And in total, manganese amounts to 2 plus 1 is equal to 3. Okay, now we can easily balance it. So look at the oxygen number, and basically we have our answers. Maybe they just want the value of A, right? So A should be, this one should be 3. It can't be 2, right? It's between B and C. And what about C? C should be 2. So the answer is C actually. Okay, that's what they wanted. Balancing water and hydroxide is not essential here. Hopefully you guys understood. 13. Actually 12. Now 12. Methanol can be produced from hydrogen and carbon dioxide. What is an expression for Kp? So Kp is, remember, partial pressure of product by partial pressure of reactants. So partial pressure of methanol above and partial pressure of hydrogen square multiplied by the partial pressure of carbon monoxide below. So do you see the issue in D? There's an extra 2. We don't need this 2. This is wrong. So the answer is C. And A and B have been inverted. 13. 4 grams of powdered calcium carbonate are added to 100 cm cube of 0.1 mole per gm cube of hydrochloric acid. The volume of carbon dioxide produced is recorded every 30 seconds. Which row of the table is correct? Why the rate of reaction changes with time? Over time, as you can see, rate is decreasing, right? Look, we got 40 here, 30 here, like cumulative frequency. We had 18 here, okay, 13 here, 9 here, and 0 here. Basically because, you know, reactant is being used up. The reactant is being used up, so we have fewer collisions over time, right? That's why the rate actually decreases. It's between A and B. Why does the reaction stop? We need to find out the limiting reagent, right? So calcium carbonate reacts with HCl to form calcium chloride in this ratio. It's a ratio of 1:2. So this has a mass of 4 grams. 4 by 100 mass by mR is 0.04 moles. What about HCl? It's 100. HCl is 100 by 1000 into 0.1. So 100 by 1000 into 0.1, that's 0.01. Okay, 0.01. So clearly, guys, look at the limiting reagent. For 0.04 calcium carbonate, we're supposed to have 0.08 HCl, but we're lacking there. Okay, so HCl is actually the limiting reagent, so HCl is being used up. Okay, we have excess calcium carbonate. 14. Which statement about ideal gases is correct? Ideal gases have finite particle volume and no intermolecular forces of attraction. So no intermolecular forces is fine, but finite volume looks incorrect. It should be zero, negligible. Okay, so C is the better answer. Okay. 15. A mixture of gases consists of 12 grams of hydrogen, 42 grams of nitrogen, and 4 grams of helium. What is the mole fraction of hydrogen in the mixture? Okay, so this is a gas. It should be diatomic. 12 by 2, that's 6. 42 by 14, 3. And 4 by 4 is 1. So the mole fraction of hydrogen, right? 6 divided by 6 plus 3 plus 1. How much is that? 6 divided by 6 plus 3 plus 1. That's actually 3 by 5 or 0.60. So 15 should be B. So what did I do? Wait, did I make a mistake? Wait, I just dropped the pen. A mixture of gases contains 12 grams of hydrogen, 42 grams of nitrogen. Oh, sorry, I used the wrong MR for nitrogen, right? So nitrogen also exists as a diatomic molecule. Each nitrogen is 14. My bad, guys. Each nitrogen is 14. So it should actually be 28. Okay, 42 by 28 is 1.5. So the mole fraction of hydrogen, right? So 6 by 6 plus 1.5 plus 1. That's actually 0.706 or 0.71, right? So 15 is actually C. 16. What is the definition of the bond energy of the BR-BR covalent bond? Remember, bond energy is always defined as the energy required to break the bond. That's just the convention. So it's not making the bond, it's actually the endothermic one, that's the convention. Energy required to break 1 mole of BR-BR bonds. Now remember, it doesn't have to be the standard state. It always needs to be in the gaseous state. So we need to atomize anything first. We need to atomize an element first before we break the bond. So it needs to be in the gaseous state. Which graph correctly shows the relative melting points of the elements? Magnesium, aluminium, silicon, and phosphorus plotted against the relative electronegativities. Melting point. A is wrong because silicon has the highest melting point, okay? So A is wrong. D is also wrong. Now let's look at the periodic table, right? Do I have it copied or something? Yeah, I do. So this is in the third period. Magnesium, aluminium, silicon, phosphorus. Magnesium, aluminium, silicon, phosphorus. So the trend is like this. Sodium, magnesium, aluminium, silicon, phosphorus. So phosphorus actually has the highest electronegativity. That's why C is wrong. 17 needs to be B. Okay. Now for 18. An excess of magnesium oxide is shaken with water. The resulting mixture is filtered. This is filtrate W. 2 drops of dilute sulfuric acid are added and any observation is noted. Okay. So after MgO is shaken with water, we're going to get magnesium hydroxide, which is actually insoluble. Do you get it? It's insoluble. So after it's filtered, an excess of MgO is shaken with water. The resulting mixture is filtered. This is filtered W. 2 drops of dilute sulfuric acid are added and any observation is noted. This is the first one. And then the next one, that's a W, right? So in W, we basically have like, this is a PPT. This is solid, right? So after filtration, the magnesium hydroxide will be stuck here and water will pass through. Get it? For W. And now for X, what happens? We're going to get barium hydroxide, which is in fact soluble in water. Okay, this is aqueous, very soluble. So if you pass it through the filter paper and the funnel, we're going to get barium hydroxide here. This is an alkaline solution. So 2 drops of dilute sulfuric acid are added and any observation is noted. So if you add sulfuric acid here now, H2SO4, you're going to get the white precipitate barium sulfate. So we are going to get a white precipitate for filtrate X. Okay, we're going to get a white precipitate for filtrate X. We're not going to get a white precipitate for filtrate W because basically magnesium sulfate is soluble in water. Okay, so W and magnesium hydroxide gets stuck. Okay, it doesn't even pass. So B can't be the answer. The best answer for 18 is actually X, right? I told you we're gonna get a white precipitate for filtrate X. Also, filtrate X has a very high pH, right? I told you it's really alkaline compared to water in filtrate W. So yeah, D is the better answer. 19. Samples of magnesium carbonate are placed in crucibles S. The sample in crucible R is heated until there is no further loss in mass and then allowed to cool. Okay, so basically R was heated. Magnesium carbonate was broken down to form magnesium oxide and carbon dioxide. The sample in crucible S is left unheated. Dilute HCl is added to both the crucibles, right? So this is R and this is S. We have magnesium carbonate here and we have magnesium oxide here. On adding the dilute hydrochloric acid, what observations are correct? So on R, when we add HCl into crucible R, right, MgO plus HCl actually gives us MgCl2. Acid plus base is equal to salt plus water. Okay, neutralization. What about S? Magnesium carbonate plus HCl. That's going to give us magnesium chloride salt plus carbon dioxide plus water. So a gas will be produced for S, but in R we will see no gas. Okay, that's why 19 should be C. 20. When concentrated sulfuric acid reacts with sodium iodide, the products contain sulfur, iodine, hydrogen sulfide, and sulfur dioxide. Which statement is correct? Basically, guys, iodide was oxidized. Okay, hydrogen sulfide is the product of a reduction reaction. This is 100% true because iodide. Do you understand? Iodide was oxidized to form iodine, and the sulfur in sulfuric acid was actually reduced to form hydrogen sulfide, sulfur dioxide, and yellow sulfur. Okay, iodide ions are stronger oxidizing agents. Wrong. Sulfate ions are stronger oxidizing agents than iodine, or iodide ions are stronger reducing agents than sulfate ions. Okay, sulfur atoms from the sulfuric acid are both no only reduced. Sulfur atoms from sulfuric acid are oxidized, no reduced to make sulfur dioxide. 21. A solution of sodium hydroxide reacts with 3 moles of chlorine under certain conditions. The reaction produces 5 moles of sodium chloride and 1 mole of X and only one other chlorine containing product. Okay, this is an important question because you need to have this memorized. The answer should be C. There are two possible answers in this scenario, A and C. So for this particular scenario, this is in hot NaOH. Hot NaOH reacts with 3 moles of chlorine basically, and this is a disproportionation reaction to form 5 moles of sodium chloride, right? 1 mole of X and 1 chlorine containing product. So check this out, guys. Sodium chlorine had an oxidation number of 0. It turned into -1 here. So in total 5 electrons were lost. So in the other compound NaClO3, this is -6. Chlorine needs to, like, chlorine gained 5 electrons there, so chlorine needs to lose 5 electrons to form this. Okay, let me explain this in a better way. Wait up. You basically need to have this memorized. That will make your life easier. So yeah, it's not erasing for some reason. Okay, so we have NaClO3 and 1 mole of X, that's water basically. So yeah, we need 6 moles of this. Do you get it? This goes from, sodium remains the same. This goes from 0 to, -1 here. But there are 5 in total, so 5 electrons have been gained. This goes from 0 to, this is -6, this is +5, 0 to +5. So 5 electrons have been lost. It's balanced out. And we need 1 mole of water. That is the final part, okay? It balances out, I guess. Check it out. Wait, no, we don't need water. My bad. Wait, let me check. Um, a solution of sodium hydroxide, okay, reacts with 3 moles of chlorine. The reaction produces 5 moles of sodium chloride and 1 mole of X. Yeah, the only other chlorine containing compound. Yeah, but we need to deal with this hydrogen, right? Check this out. In total, we have water here. We have 3 atoms of oxygen on the right hand side, but we need 6 in total. So we need a 3 over here. Now this matches, okay? Sorry about that. Moving on to 22. Redox reactions are common in chemistry. So we have fluorine, chlorine, bromine, iodine. We also have fluoride, chloride, bromide, iodide. Oxidizing power decreases down the group. So chlorine can oxidize bromide and iodide, but bromine cannot oxidize chloride. Similarly, iodide is the strongest reducing agent. Clear? So bromide ions will reduce chloride but not iodide. Okay, so hear me out. If we think about oxidizing power, if you're above, right, fluorine can oxidize chloride, bromide, iodide. Chlorine can oxidize bromide, iodide. Bromide can oxidize iodide but cannot oxidize chloride, for example. Now, if you're thinking about reducing power, iodide can reduce bromine, chlorine, fluorine. Bromide can reduce chlorine, fluorine, but not iodine. So A is actually correct. So please try to understand what I'm trying to say. And fluorine is the strongest oxidizing agent, and iodide is the strongest reducing agent. 22A. 23 now. Which statements describe a trend in period 3 between every pair of adjacent elements from sodium to chlorine? The every pair of adjacent elements, the atomic radius decreases. This is correct, okay? Like ionization energy doesn't work. You know why? Because it doesn't work for every pair. Like not this pair, not this pair. That's why this is wrong, okay? And we aren't supposed to know about melting point in. No, we are supposed to know about these trends. The trend for melting point is like this. It increases, right, like this, and then silicon is a huge increase followed by this, okay? Yes, that's melting point. And conductivity is high for metals. It's more or less high for silicon. It's a semiconductor, and then low for the other ones. Okay, you need to memorize those trends, right? 24. Nitrogen forms pollutant oxide Y in a car engine. Further oxidation of Y to Z occurs in the atmosphere. Okay, so nitrogen oxide. Nitrogen reacts with Y. Nitrogen forms a pollutant oxide Y, NO. Y is NO. So further oxidation of Y to Z. So NO plus oxygen, we get NO2, nitrogen dioxide. This is our Z. Now in this further oxidation, 1 mole of Y reacts with 0.5 moles of gaseous oxygen. Which statement is correct? Z does not react further in the atmosphere. That's wrong, because Z actually reacts with sulfur dioxide, right? It helps in the catalysis of acid rain formation, so that's wrong. B, a molecule of Y has 50 electrons. Okay, nitrogen monoxide. Okay, nitrogen has 7 electrons, oxygen has 8. 7 plus 8 is equal to 15. That's good. 24B. 25. Structure isomerism and stereoisomerism should be considered when answering this question. Each of the following carbonyl compounds is reacted with sodium borohydride NaBH4. The product of each reaction is heated with aluminum oxide, giving either only one isomer or a mixture of isomers. Which carbonyl compound will produce the most isomers? Okay. Butanal, CH3, CH2, CH2, CHO. This is reduced to form CH3, CH2, CH2, CH2OH, right? Now this is dehydrated to form CH3, CH2, CH, CH2. This only has one isomer, okay? No cis strands, only one isomer, so it can't be A. Probably it can't be A. Now let's look at B. Butanone. CH3, CH2, CO, CH3. This is reduced to form CH3, CH2, CHOH, CH3. Now what? This can be dehydrated to form either CH3, CH2, CH on this side, CH2, one isomer, or it can form CH3, CH, CH, CH3, butene, which has two cis trans isomers. So in total, it has three. This is a probable candidate. Pentan 3-on. CH3, CH2, CO, CH2, CH3. It doesn't matter whether you go right or left, right? Because you're going to get the same compound after um, reduction. CH3, CH, CH, CH2, CH3. It has two cis trans isomers, so it's gone. Now, what about propanone? CH3, CO, CH3. We can just get CH3, at first. Oh, I missed a step here. We're gonna get CH3, CH2, CHOH, CH2, CH3 first, then this, okay? So we're gonna get CH3, CHOH, CH3 followed by the only possibility CH3, CH, CH2. Do you understand? So that has only one isomer, no cis strands, okay? So one. So we're gonna go with B because it has three isomers. 26. So some kid was asking in the comment section, what do we do with molecules like cortisone? If you're watching this, shout out to you. So I'm going to show you what we do. The drug cortisone has the formula shown. So basically, remember that bigger compounds are easier to solve. Just don't get scared, okay? In addition to those chiral centers marked by an asterisk, how many other chiral centers are present? So I'm going to teach you the trick. I ignored these basically because these have two hydrogens attached. They can't be chiral. Also, I ignore sp2 carbons, carbons that have double bonds, because if you have a double bond, you can't have four different atoms attached to you, right? So we're going to ignore those. I'm going to ignore this. These are going to be ignored, right? So this is ignored, this is gone, this can't be it, this can't be it, this can't be it. Okay, so these are all gone. Now let's look at this. Look at this group over here. Above you have CH3. On the right and left, these clearly don't match, right? Unique groups. And below we have a double bond. This is also unique. So I'm gonna go with this. This is a chiral carbon. This can't be chiral, right? This can't be chiral over here because it's a double bond. This can't be chiral, this can't be chiral. These have been marked. This can't be chiral, this can't be chiral. This is chiral again, okay, because it has four unique groups attached. These two can't be chiral because of the same reason I told you before. Okay, what about this? This is chiral clearly, right? Because OH group and three other different groups. This can't be chiral, this can't be chiral due to the CH2 and double bond. So that's it. Aside from these, we have three other chiral carbons. So the answer is D. You're gonna have a question like this, okay? Trust me, in your P1. So be careful about this and do other years. 27. An alkene is reacted with acetate KMNO4. The organic product has a relative molecular mass greater than that of the alkene by 34. Which conditions should be used? Interesting. So look at this. It's not cold concentrated or hot dilute. It's between these two. So look at this alkene. Suppose we have CH2, CH2. After cold dilute KMNO4, we're gonna get CH2OH, CH2OH. So what's happening? Basically, two OH molecules were attached. Each OH molecule has an MR of OH is 16, hydrogen is 1, 17. 17 plus 17. That gives us a value of 34. So 27 is actually 34 in total. So yeah, it should be cold dilute KMNO4. Okay. Hot concentrated is too vast. There are too many possibilities. 28. The diagram shows the short length of an addition polymer chain. The polymer has a relative molecular mass of 100K. So 10,000. So this is one repeat unit. the MR of each repeat unit is 12 into 2 plus 4. That's 28. Okay, so 10,000 by 28. That gives us an approximate value of 357. They gave you two repeat units to confuse you, right? So the best answer should be B, 360. 350 is round off to 360. Lactide is an intermediate in the manufacture of a synthetic fiber. Which compound on heating with acid catalyst can produce lactide? So you know that we use H2SO4, concentrated H2SO4 catalyst for esterification. By the way, I'd highly advise you guys to watch my AS organic chemistry video in 40 minutes. Um, I'm gonna link that above in a card. You can watch that. It's gonna be helpful if you struggle. Also, one more thing. In the A2 chemistry video, there's a chapter called bonus. I think that's going to be helpful for you guys as well. In that section, I've talked about all the conditions for all types of reactions and what NABH4, LiH4, what they can reduce. When do we use KMNO4, etc. All right. So you can check that out as well. So the trick in this type of question is basically locating the ester bond. Break it then. Now try to draw the compound. Look, 1 carbon, 2 carbon, 3 carbons. Or here, 1 carbon, 2 carbon, 3 carbons. So basically, this is the ester bond. An ester always has two components, the carboxylic end and the alcohol end. Okay, so I'm gonna isolate this compound. I'm gonna deal with this section, all right, the pink section. So look at this. What do we end up with? So we have this here, this, and then O. So the trick is with the double bonded O, just add an OH, and with the single bonded O, just add a hydrogen. That's literally it. So remember, in your compound, carboxylic acids will always get priority in naming. The compound that gets priority will always be at the end. Now look at the number of carbon atoms for this compound. How many do we have actually? So this is carbon number 1, this is carbon number 2, and this is carbon number 3. So the compound is actually COOH, CH, CH3, OH. Carbon number 1, 2, 3. So this is actually a 3 carbon carboxylic acid. So it's propanoic acid, and the hydroxy group is attached to carbon number 2. So it's actually 2 hydroxy. Alright, it's 2 hydroxy propanoic acid. So 29 should be C. Understood? 30. Diols in which both hydroxy groups are bonded to the same carbon atom spontaneously eliminate a molecule of water to produce a carbonyl compound. Which compound is hydrolyzed to form a product that gives a positive reaction with 2,4-DNPH but not with fillings? We're basically looking for a ketone, not an aldehyde. Okay. So the first one is CH3, CH2, CHBr. This is 1,1-dibromopropane. Okay. So after hydrolysis, we're gonna get this compound CH3, CH2, CHOH, and after further hydrolysis, what are we gonna get? It's gonna spontaneously eliminate a molecule of water. We're gonna get rid of this OH and one hydrogen from here to get H2O, and we're gonna get CH3, CH2, CHO, right? CHO. After losing that molecule of water, minus H2O is equal to, this is an aldehyde. Okay, so basically this is wrong since you know, it's gonna give a positive fillings. Just now let's look at 1, 2. This is CH3 CHBr CHBr CH2Br. So after hydrolysis it's going to turn into CH3 CHOH CH2OH. Okay, this compound won't spontaneously hydrolyze. Do you get it? So it's not going to turn into a carbonyl compound. So B is wrong. Basically, if it's not on the same carbon, there's no point in checking it out. Like this is 1 3, this is 1 2. So B and C are wrong. It should be D. Why? Look, check this out. CH3 C Br CH3. After hydrolysis, this turns into CH3C OH OH CH3. So after you get rid of one molecule of water, you're going to end up with CH3CO CH3. Understood? And we're going to get a ketone, which gives a positive test with 2,4-DNPH, but a negative test with the with Fillings reagents. So the answer is D. This is also a common MCQ. I've seen this before, maybe in Feb March 17. You can check that variant out. 31. X and Y reagents required to convert 1 bromopropane into butanoic acid. Really important. Nucleophilic substitution took place. We used KCN in alcoholic in ethanolic conditions in the first step, nucleophilic substitution, followed by acidic hydrolysis of the nitrile to form carboxylic acid. Really important reaction. 31C. 32. Q is a compound with molecular formula C4H10O. Q can be oxidized with acidified potassium dichromate. Q cannot be made by reducing a carboxylic acid with LiLH4. If you reduce a carboxylic acid with LiLH4, you're gonna get a primary alcohol. That's why Q can't be a primary alcohol. That's the thing that we need to take from this info. Because if you reduce, suppose if you reduce propanoic acid, okay, using LiLH4, you're gonna get CH3 CH2 CH2OH. You're gonna get a primary alcohol. But Q cannot be made like that. That's why primary alcohols are out of the question. Now, it can be oxidized using potassium dichromate. This is a secondary alcohol which can be oxidized using potassium dichromate. A is the answer. It can't be C because tertiary alcohols can't be oxidized. 33. A sample of 2.3 grams of ethanol is mixed with an excess of aqueous potassium dichromate. So yeah, guys, we actually saw this question in Feb March 2022 maybe. I did this. One of you asked me that, like, after we distill, right, aren't we supposed to get an aldehyde? But look, the time matters. We kept it for 1 hour, right? That's enough for the primary alcohol to be converted to a carboxylic acid regardless of distillation. Okay, if you distill it within 5 minutes, it would have been the aldehyde. Okay, but 1 hour is too long. So ethanol CH3CH2OH turns into ethanoic acid after 1 hour of heating under reflux. Okay, so we had 2.3 grams of this. What's the MR? 12 into 2 plus 16 plus 3 plus 2 plus 1, that's 46. So 2.3 by 46 is 0.05 moles. So the molar ratio is 1:1. We're going to get 0.05 into 60% on the right, into 60 by 100. That's 0.03 moles, right? 0.03 moles. Now, what's the mass of the product? What's the MR of this actually? 12 into 2 plus 32 plus 3 plus 1. That's 60. MR is 60. So 60 into 0.03. How much is that? That's actually 1.8 grams. So we're going to go with 33C. Are we clear? 34. Compound R gives a positive test with aqueous alkaline iodide. It does not display stereoisomerism. So it has, it may have a methyl ketone group. And it does not have stereoisomerism. So basically it has no cis strands or chiral carbons. A looks like the answer because it has the methyl ketone group over here and no chiral carbons. Okay. B does not give the methyl ketone. Does not give the aqueous alkaline iodine test. It's a negative test. Okay. This has the methyl ketone group, but it has a chiral carbon. So C is gone. D. It's a tertiary alcohol. Okay, so it can't give a positive test. If it was secondary, it would have been possible, but no, it's wrong. 34D is wrong. 34A. 35. Citral is found in lemongrass oil. It can react to give compound W. Remember, guys, nickel can only reduce alkenes. Could I clarify? Nickel can only reduce alkenes, not aldehydes. So after reduction, if you want to see compound V, this is compound V. This is compound V. I just got rid of the double bonds. Now, after hot esterified KNO4, what's going to happen? The aldehyde is going to be oxidized to form a carboxylic acid. No rupture or cleavage, no oxidative cleavage will take place here. Okay, so this is the compound we're looking for. Answer B. 36. P and Q are alkenes. They are geometric isomers of each other. P and Q give different products with not really. So what's the difference between geometric isomers? Try to understand. They're molecules with the same structure formula but different spatial arrangement of atoms. Okay, they have the same empirical formula and they have the same functional group. So what's different? The spatial arrangement of atoms, or we can say it's the skeletal formula. Check this out. This is cis butene. This is trans butene. Get it? The others are the same. 37. The following statements are about the reaction of NaOH with 3 chloroalkanes shown. Which statement is correct? So it's about nucleophilic substitution. This is a secondary halogen alkane. This is primary. This is 3 degree. So this one, the primary halogen alkane, right, this one, reacts by SN2 mechanism, which is correct. This is true. Primary, remember, primary is SN2 and tertiary is SN1, and secondary can take part in both. The tertiary chloroalkane reacts more quickly than the others because the carbon atom bonding to C atom is more positive. No, it actually reacts more slowly. Do you understand? Because it occurs in 2 steps, and the first step is a slow step. It's much more stable. The Cl atoms in the 3 chloroalkanes are attacked by OH minus. No, the electropositive carbon atom is attacked. The molecular formula of the major product is C4H8 for each reaction. Is it though? Let's see. CH32 CH CH2OH. So that's actually 1 2 3 4 C4 1 2 3 4 5 6 7 8 9 10 H10O. This is the molecular formula. Okay, so D is wrong. We're gonna go with 37A. Last 3. 38, which is described correctly. Pentanal aldehyde plus fillings. Fillings reagent actually gives us a brick red PPT. So yeah, 38A is correct. Pentanal plus hot acidified potassium dichromate. It goes from orange to green. It has been inverted. Pentan 2-one plus warm tolerance. No, nothing is seen. It gives a negative result. And C6H14. Acidified. An alkane doesn't react with potassium permanganate. It's wrong. 39. Which statement is correct? C3H7COH can be used to form propanoate in a single reaction. CH3CH2 CH2COH. Not really. How? It can't. It's not possible, okay? It's impossible. The empirical formula of this is the same as the molecular formula. Let's see. It's C4O2H8. No, it can be simplified to C2OH4. So B is wrong. C. Each of C3H7OH and C3H7COH reacts separately with it. No, NaBH4 is not strong enough to reduce the carboxylic acid, and alcohols can be reduced. So that's wrong anyway. So 39 should be D. Each of these two, propan-1-ol and butanoic acid, reacts separately with sodium metal. True. Alcohol is acidic enough to react with sodium active metals to form alkoxides. Yeah. 40, last one. IR as usual. So how do I view these compounds? Just look at my thought process. I mainly look at 2 peaks, okay? I look at the peak at 1700 That's the peak for the strong peak is for carbonyl. And I just look at, hydrogen bonding, the broad peak. This represents hydrogen bonding in COH, OH, or NH. So we have carbonyl as well as hydrogen bonding. So let's try to figure out the compound. What's the question? What can be deduced about X? It is an aldehyde or ketone. Wrong, because aldehydes and ketones do not have hydrogen bonding. It is an alcohol. Wrong. Alcohols have hydrogen bonding, but it does not have the carbonyl group. C is perfect because it has both the carbonyl and the peak for hydrogen bonding. Okay, so guys, that's it. Probably the last chem video I do before your exams. So good luck on the 7th. And if you don't understand anything, you just comment down below. I'll try to get back to you guys. So I'm gonna link the playlist for paper 1 up here, and I'm gonna link 9701 Feb March 2022 variant 1 2 up here, and I'm gonna link the video for AS organic chemistry down here if you want to see that, right? And I have the whole series for 2021 solved, so you can check that out in my channel. Okay, and remember to subscribe to the channel if you love the video. See you guys.